Hello students, welcome back to another video session, and this particular lecture is mainly for the foundation course program. That means this is definitely for class 9. In this particular lecture I am going to discuss few numerical problem based on motion in graph for the students of class 9, those who not only needs to know these things to answer their basic course as per the syllabus. Rather, this learning can help the students to know more in details so that their objective to crack IIT or NEET in coming years will be really helpful through this video lecture. So let's begin. So as I said that I will discuss kinematics or motion in graph, right? Motion in graph. So in graph based motion I have already discussed a few things based on the foundation objective is concerned, the foundation course concept is concerned. So now here I would like to discuss the things in terms of problems, right? So suppose this is given an ST relation, ST graph, t is in second in x-axis and displacement in as a meter, unit of the displacement in meter taken on y-axis. So a ST graph is showing like this. It is a straight line that is making 30-degree angle passing through origin. Now if I ask you that find velocity from this S versus t graph, right? Find velocity from this S versus t graph. So for all of you, it is the basic concept, basic learning that whenever we discuss the ST graph, so you must be knowing about it. The slope of the ST graph, right? The solution will be slope of ST graph, right? This graph represents, slope of ST graph represents velocity. So as because the slope of ST graph that represents velocity, so here this line, this y is equal to, we know that since line is passing through origin, right? Passing through origin, we can say origin coordinate is 0, 0. So whenever we refer the point 0, 0 means it speaks about the point origin only. So line is passing through 0, 0 means its equation is y is equal to mx, right? So m is equal to slope of the line, and this is decided by tan of the angle what it makes with the time axis. So here for this particular line you can see, here for this particular line the slope, that is the angle what it makes with the time axis according to the graph is 30 degrees. So and that 30 degree geometrical angle remains same everywhere. That's why it is a straight line. A straight line will make a constant elevation throughout of its existence. So as because it is continuously making the same elevation at everywhere, so that's why tan 30 whose numerical value is 1 by root 3. So this numerical value 1 by root 3, this will be meter per second, right? This numerical value as because the slope is equal to the velocity. So velocity of this particle is 1 by root 3 meter per second. Is that clear? So we have been asked about the velocity of the particle whose motion is represented by the ST graph as shown in the diagram. So yes, definitely the slope of this line is the numerical value of tan of 30 degrees. So here the velocity of the particle is 1 by root 3 meter per second. Well, moving to the next question. Next question will be again based on the graph. As I said that today I will discuss the graph based problem only. So again it is based on displacement time graph right now. So suppose there are two lines now drawn, both of them are passing through the origin, right? Both of them are passing through origin. Now one of them makes 30-degree angle, another one is making 45-degree angle. The line that makes 30-degree representing the motion of an object A, and let the line representing the motion of B is at an elevation of 45-degree, right? So now here I need to know that find velocities of A and B, find velocities of A and B, and at the same time if you are asked that who is moving faster, who is moving faster, right? Who is moving faster? So quite obvious, the one who will be having the greater velocity value is definitely moving faster than the other one. So as we know that, again like the previous one, the slope of the line that represents velocity. So here I can write down the answer in this way, saying that slope of line A, that line A is basically velocity of particle A, right? If I consider these are the two distinct particles, so let A is one particle, B is another particle, their displacement time relation is given in graph, right? So from that part we need to know their respective velocities. So velocity of particle A will be the slope of the line. So this implies that velocity of A, VA, if I am represented by VA, it will be the numerical value of tan 30 degrees. So right, I have already seen the last one where tan 30 we know it comes 1 by root 3, that value will be unit in meter per second. Similarly I can write down slope of line B, slope of line B, that will be the value of velocity of particle B, right? Velocity of particle B will be decided by the slope of the line representing the motion of B. So here also I can write down the velocity of the B will be the numerical value of the tan of the elevation, so tan 45 degree, and we know that tan 45 degree is numerically 1. So here by knowing the slope of the respective line, those who are representing the motion of two distinct particles A and B, so by using the slope value we can answer about those two particles velocity, that is velocity of A is 1 by root 3 meter per second, whereas velocity of B is 1 meter per second. So who is faster? So definitely it is B. Slope of B is more, that's why velocity of B is more. So as because VB is found greater than VA, means B is moving faster, right? Means B is moving faster, right? B is moving faster than A. Okay, I hope you are able to understand these questions, right? So now in the next question, if I say that again in a displacement time graph, time in second, displacement S in meter, right? If I say that a particle is shown its motion by this graph, okay, a particle has been shown by drawing a curve on xy plane representing displacement versus time graph. So what will be, if the question is asked, what will be the nature of motion, represented by the ST graph. So this ST graph is definitely representing about the nature of motion of the particle, what exactly happening, is it moving with the uniform velocity, or it is moving with increasing velocity, or is it moving with decreasing velocity, right? So what exactly available here, what kind of motion is possible for that particular particle whose displacement time graph has been shown with this curve, we need to comment on this, right? So here how we can answer this, see, if we choose various position on the graph, if we choose few position on the graph at different instant, suppose this is at 0 0 means first position is at the 0 displacement and at 0 time, right? So at starting instant wherever the particle is located, that position is referred to be the starting position. From there only the displacement will be measured as soon as it starts changing its absolute position. So here we can see different measurements. Some it is at S1 at T1 second, then we are finding its position at somewhere S2, right? Its position we can observe it somewhere S2. Let this is at S2 at T2 second, and then again finally it is further located at another position, let it be S3 at further increase in time, that is T3 second. So here three distinct position has been shown here for the particle, right, with increasing in time, and the position is showing that it is definitely further moving away from the starting position. So we can say with this, as because with the increase in time spent or time measured, as the position is increasing, so therefore we can say it is, first statement we can make, it is a unidirectional motion. It is a unidirectional motion. That means the body is moving in one direction only. Unidirectional motion, and that is the reason why along the motion direction the displacement measured is continuously increasing. At one instant it is at S1, at next instant it is at S2, next to that it is at S3. So we can see from the starting point the measured separation is increasing, so that means it is definitely going in one direction only. So first statement we can make, it is unidirectional motion, means it is continuously moving in one direction till its existence. Now the second statement we can make here, the second statement suggests us that if we draw velocity at various points, suppose if we draw tangents, at various points, then we can see those tangential line on the graph will make different elevation with increase in time. So suppose if I mark those points, with the letters like A, B, C, okay. So elevation of the tangent at A is suppose theta 2, exactly at O it is theta 1, then at B it is theta 3, and then finally at C it is theta 4. So we can see this elevation of the tangential line on a bent path or on a curved path defines the slope of the line at that point, right? Slope of a curve, that is tan of theta, that can be found by drawing a line touching the curve at one point. So the line which touches the curve at one single point, that line is said to be tangent to the curve at that point. So that's the reason why distinct lines can be drawn touching the curve at various points. At O, the line which is touching the curve is different than the line that is touching the curve at A, which is further different than the line which is touching the curve at B. So this way we can see the tangential lines are distinct at a distinct position, right? Is that clear? So therefore I can write down at O slope, we can measure it like this, we can write down like this, slope equal to m at O, and that will be equal to tan of theta 1, right? Similarly at A, slope is equal to m at A, and that is decided by tan of the elevation theta 2. At the point B, slope is equal to m at B, that is tan theta 3. And similarly at C, where we can see slope of line is equal to m at C, that will be equal to tan how much? Theta 4. So this is the way we can see different lines at different point is used to touch the curve, and that line which touches the curve at one point is said to be a tangential line for the curve, and elevation of the tangential line at that particular point will be deciding the slope value on behalf of the curve. Instead of curve, if we get a straight line like what we have discussed in previous question, there we can see by a straight line slope is same throughout of the length of the line, but for a curve the slope changes from one point to another point. So as because this particular curve moving from one position to another position for increasing time, we can see continuously the slope values are decreasing. You can check it out. Tan theta 1 is more than tan theta 2, which is further more than tan theta 3, and finally which is more than tan theta 4. So from this results I can say slope at O greater than slope at A greater than slope at B, which is further greater than slope at C. So this means the velocity at O, slope is decided by velocity, is greater than velocity at A, which is further greater than velocity at B, and finally it is velocity at C. Are you getting me or not? So this is the way we can relate the velocity at different points. So based on this observation, based on this argument regarding this motion, we can say two things. One most important thing that I have already said, that it is unidirectional motion. It is only one direction motion. Particle is not returning back. It is traveling in one direction from starting instant to till the discussion is done. So everywhere it is moving in one direction, and along the direction of motion its velocity is decreasing. So here we can say one thing regarding the observation, that particle is moving in one direction. Particle is moving in one direction only, where velocity of the particle decreases continuously. Is that clear? So this is what we can comment about this particular graph regarding the nature of motion. So finally, what is the nature of motion? We are observing it here. We can say that particle is definitely traveling along a straight line where velocity value is continuously decreasing, right? And that decrease in velocity is decided by observing the slope of the tangential line on S versus T graph at various points. Is that clear?